Hey guys, so we're this day 2 of domain and range, and today what we're going to do is we're going to be looking at different graphed lines on a coordinate plane, and we're going to describe them with an equation or with an inequality. Now this is a kind of a day that you really need to pay attention to detail. All the little bits and pieces you already know, but we're going to be putting them all together, and it just means a lot more processing going on in your head. This isn't as easy as putting in, if x is this, putting it in and getting y out the other side. Like this is actually kind of processing what you're seeing and writing it in a way that is truthful. So we're going to look at this first one. It is a linear function, and linear just means a straight line, and it's a function or an equation that if you graph x and y, it will create a straight line. And so this particular one is going on and on and on forever. You can see the arrows on both sides. You've created these, I'm sure, dozens of times throughout the last couple of years of your math life. Now we're going to describe them in an equation. That part might be a little bit new. So domain, remember, you always want to ask, well, what is domain? And I'm going to be trying to switch around with different colors and stuff. I'm not very good at it. This is still kind of new for me, so please be patient. So domain is my x. And so domain is your x-axis right here. And you can tell that this arrow, if it kept going on, and if this arrow kept going on, it's going to cover all of the numbers on the x-axis to infinity. And so the equation to describe that, to describe domain, would be x equals all real numbers. Same with the y. The y-axis, which is right here, that's my range. Again, you can see if this arrow goes on and on forever and this arrow goes on and on forever, then it's going to cover all of the numbers on a y-axis. So y equals all real numbers. Let's look at example number 2. So example number 2, we have a vertical line. And so one thing that we know about a vertical line on a graph is that all of the x values are going to be the same. So if I named this, x would be 7. If I named this in this ordered pair, x would be 7. If I named every single one of them, x would be 7 for any one of the ordered pairs I name. So to describe the domain, which remember, domain is x, x is 7. X is 7 in this situation isn't the answer to an equation. It is the equation. It is the equation of the line x equals 7. For the range, remember range is this whoops. Okay, sorry, I'm trying to use color here. Here's my y-axis. And you can see that it's going to be all real numbers. I'm not going to go into much more explanation than that. Now, number 3 and 4, these are quadratic functions. We're going to spend a lot of time talking about quadratic functions, but up until Christmas, it's mostly going to be just looking at them and talking about characteristics about them as opposed to actually doing other things with them. So a quadratic equation is a U-shaped line, and it does that because the variable x is squared. So if the variable x is squared, you can just look at that equation and go, that's a quadratic equation right there. If you graphed it, it would always create this U-shaped line. So here again, I'm going to exaggerate this line. I'm going to go ahead and exaggerate it up going this way and exaggerate it up going this way, just to emphasize that this is the x-axis. And if those arrows go on and on forever, it's going to be the x, or the domain, is going to be all real numbers. The y, on the other hand, let me erase some stuff here. The y, on the other hand, starts here. Because again, this is the y-axis. Just go ahead and show you this is the y-axis. So it starts here, and then it keeps going forever and ever and ever. So y is greater than or equal to -4. It's equal to, I know you don't see a solid dot, that usually is what you use when you're saying it includes it. But if there's a line on a graph and it touches, it's kind of like a solid dot. So the next one, it's the same thing, only this time it's a parabola. The quadratic equation is flipped upside down, or the parabola is flipped. And so now x is still all real numbers, because again, if I exaggerate this, it would, you can see that it would cover if it's going on for all infinity. And that, but the range, it starts here and then it goes down. So x is less than or equal to 8. Let's keep going. Exponential functions. Again, we won't talk as much about exponential functions this year, but it's a line that the variable x is the exponent. So if you ever see that, that's an exponential function, and it will always kind of come down this L shape, or a backwards L shape, and it approaches what we call the asymptote line, but it never will actually touch it. So if you look here at this equation of the line, it's coming down. It sure does look like it's touching the x-axis, but because the x-axis is the asymptote, it is not going to touch it. So here at this line is where y is 0. So it's never going to touch it. So the range is y is greater than that 0, because it's everything above it. This equation of the line is going up forever and ever and ever, but it actually never passes the 0. So the y is greater than 0. For the x, you can see that it's going to go on and on and on forever because of this arrow here and this arrow here. All the x's will be covered, so domain is all real numbers. And then if you look at example number 6, it's the same thing. The asymptote, the asymptote does not have to be this, doesn't have to be the x-axis. It can be another line, or whatever the asymptote is, it will never touch it. So again, even though that this quadratic equation is flipped, it's still x equals all real numbers for the domain, and y is greater than 0 for the range. And so that's pretty much what you're going to be doing for your assignment. You're going to be looking at different graphs, and you're going to be describing them with an equation or an inequality, what we call an inequality notation. And then also you'll be mixing them up. Yesterday we did inequality notations, but we also did what's called set notations. And so, we talked about sets of numbers and being in brackets. Well, that's a set notation. So that's just another way to show what the domain and the range is of a function. Okay, that's it. Be careful. Don't do what I do and be careless and work too fast and make a bunch of mistakes. I'll see you later. Bye-bye.